So with that, I think we shall get started with the first presentation. And I do have the luxury that I can sort of start when you want.
Okay. I want to warm up a little bit.
One more thing, this is very welcome and can also be done during the presentation. It's fine to speak a little bit.
Okay. So once it starts rolling, I can't stop. Well, my name is Neil, and I'm going to do a very short presentation in 6 minutes we've just heard. And it worries me because I think about this and I think about quantity and I think about quality, and I get a little bit worried about what is it we're doing here? Where does this Pecha Kucha come from? Is it good? Is it a bad thing? Is it evil? So I started to worry and I started to think about slides. Do we have too many slides? Will we end up with more slides than we started with? Is this good for us as people? So now I have to wait for the next slide because I didn't time this exactly correctly. I did my own analysis and I started looking at the ICES ASC presentations from last year. So I've developed my own data set. I've looked at 60 samples, which is 20% of last year's presentations. And from these I've taken some variables, number of slides, sex of the presenter. And the nice thing about this data set is we know there's a standard time of presentation for an ICES presentation. 15 minutes, 30 minutes, 2 minutes for questions and answers. And the first finding there, you'll see male presenters, 1 slide less on average. Why that is, I don't know. So there's some further work to be done there. But the results are in, and the average slides for ICES presentation, 17. But you can see there we have some people that want to do 34 slides, and some do half that number down to 10 slides. So there's a big variation in the number of slides that are used. So this got me even more confused. So I started to look at a metric for this. So average slide length, ASL, this is the one we have to remember, and being a scientific presentation we have to have a formula. Time divided by number of slides is ASL. So moving on from ASL, looking at the ICES presentations, the average ASL is, timing, 50 seconds. So the average slide length in an ICES presentation is 50 seconds. And you can see them there on the graph. That's the second element of a scientific presentation. You have to have a graph. And you can see the range here. So some were down to 23 seconds for dwell time on a slide, some up to 78 seconds. So big variation. But you can see there that the lowest ASL, 23 seconds, is still not Pecha Kucha compliant. So this is another worry. You know, if there was a directive on this, we would fail. So then I started to wonder again, well, so what? Does it matter if we're not Pecha Kucha compliant? So then I started thinking about presentations in general. Presentations are about telling stories. They're about conveying information from me to you about something. And it doesn't matter what it is, but I have to get a message across. So then I started thinking about, well, who is good at telling stories? And then I get... So I thought about Hollywood, the dream makers. These people are very good at telling stories. And they do it in a very professional way. They make a lot of money. And essentially what they do are make very, very expensive slideshows. So I thought about Hollywood as my basis for inspiration. And I started looking into what they do in Hollywood. And there is a branch of science, a little bit discovered, called cinemetrics. Actually, I made up the definition, but the word does exist more or less. And this is the analysis of film by maths and statistics. So something we can relate to. So in the study of cinemetrics, there is a golden metric. And the golden metric is the average shot length, the ASL. Once again, time divided by the number of shots. And here you can see the Pink Panther. And a shot is where you have one single camera sequence. So when you change or zoom or go to another camera, that's a new shot. So looking at some films, to give you some examples now, this is where it gets really interesting. So it tells you about how a story is perceived. They use ASL as a measure of something about the story. So if it's a short ASL, it's urgent, it's fast, it's action. If it's slow, it's more calm and relaxing, perhaps a dialogue-rich film. So this is how, you know, ASL can tell you something about a film. And here's a couple of examples. Inception 3.1. Brokeback Mountain, twice as long, Perth shot. This is just a pure conjecture. I couldn't say if this was a boring film. Maybe, I don't know, you decide. But this just tells you something about the narrative of that film. And here we have the Bourne trilogy. So Jason Bourne, 2002, 4.6 seconds. By the time he got to the third film, he was down to 1.9 seconds, confirming the idea that action sequels have to be more action-orientated than the first one. So this is how ASL works in the film world. And then we just have a slight interjection here. PowerPoint tip from Matt Damon, who's also very good on PowerPoint. If you press B, you get a black screen. If you press W, you get a white screen. This is quite useful in the presentation. If you've got a lot of stuff on the screen and you've got a lot of people arguing and you don't want to look at the screen, you want to have a discussion, then you can just blank it. And that's just a little tip from Matt Damon. Anyway, average shot length, as we've just seen, is an interesting metric, but it doesn't tell you if it's a good or a bad film, in the same way that average slide length doesn't tell you if it's a good or bad presentation. But it does have some value to it, it has some meaning, which is going to be on the next slide in just a couple of seconds. No, it's not. There's a cliffhanger. So we go back to our graph, just to remind us what this tells us about the presentations, and we can see that what this is telling us that we might expect that some of these are, you know, slower, more dialogue-orientated, perhaps calmer presentations, and some are more exciting, a little bit uplifting. So anyway, the main message about ASL, whether it be shot length or slide length, is a guide to the type and pace of presentation that you're going to deliver. As we see, this is a fast presentation. So is it going to be Brokeback PowerPoint or Inception PowerPoint? So this is the message I want you to remember for this little 6-minute presentation.
Don't you do a slide already?
No. Oh, that's because 2 of these aren't my slides. So further studies, being a scientific presentation once again. Overhead transparencies. Obviously, I'm too young to remember these in my working life, but there are some people here I imagine probably have some great experience with this. So,
I'm going to give a lecture in why we need to be more ethical as scientists. I want to tell you what I mean by advocacy science, why it's a bad thing to do, why it doesn't deserve to be called sound science. And we do that by thinking, what makes science special? It's not the subject matter, because we have sciences on everything from particle physics to the science of the mind. Is science special because we're trying to explain how the world works? Philosophers, religion, art, all of them have been trying to explain to us how the world works. Novelists, storytellers, poets, songwriters are probably better than anyone. Science is special because the methods we use to tell our stories have to meet a bunch of standards that we all learned, if not in high school and university. Empiricism, impartiality, objectivity, falsifiability, unbiased interpretation. We learn as graduate students. You can't make things up and put them in your thesis. You can't selectively report just the evidence in favor of your hypothesis. You can't design a biased experiment. You're an artist, you're a poet, that's fine. But now more and more when science groups, unquote, give advice to policymakers, they don't make things up, but they'll comb through the literature for the case histories that support the outcome they want. And they can even design data collection programs. They do it by picking a small set of case histories that report selectively good or bad outcomes, generalize it's categorically bad, or if they like the outcome, pick a few case histories that show it's good, and generalize this is a science-based evidence that this is a good thing to do. I'm not making this up. I was at a workshop a year ago, sponsored by 2 global intergovernmental agencies. One of them had a working paper looking at destructive fishing practices, which said most fishing practices can be or can't be. The other one, categorically good or bad. Why do we tolerate this in science? It's getting popular because we really care about the outcomes. And we think, even though we know sustainability deals with social and economic as well as environmental outcomes, we want the environmental one. We want the science to function like Siegfried's sword. It's invincible. It can break through everybody, win all the time. That's not science's role. Science's role is much more like Wotan Speer. Wotan Speer only had power as long as he followed the rules in the runes on the handle of the spear. It had power because of the rules. And when he violated them, what a damn. Now what happens when a policy decision is made? And I say this working in our headquarters for 15 years. It's an important one. A minister will get hundreds of documents from every special interest group you can think of, all selectively making arguments to the outcome they want from their perspective and with their interests. Science advice is on the top of that pile only because it comes from a structured process designed to be balanced and unbiased, setting objective, reliable standards. It gets special consideration only because of the process that produced it. And the accountability for not following it is different. For all those sectoral lobbying documents on the minister's desk, he's got to make political judgments for which he's accountable, who to favor, who not. If he ignores the science advice, everybody's after his or her ass for screwing up. And this is the error of advocacy science. If the science fails to have the objective, impartial, unbiased evidence foundation, tailoring it to support an outcome you want to support is just one more piece of sectoral lobbying. Your advice is just one more piece of paper in the huge deck of cards, and the other lobby groups are better than you are at being selective, being biased, and telling biased stories, because they don't even pretend to be constrained by objectivity and impartiality. And that's the pitfall of advocacy science. It's a slippery slope. All the other partisan players in the game have got advantages over you. And when you start playing by their rules, you have to deviate even further from science over time. It makes the, quote, science advice less and less meaningful. We can increase the impact science advice has on decision making. We can integrate the information the decision maker needs. Rather than looking for the perfect biological outcome, we look for a viable outcome on all 3 dimensions of an outcome. We've only got value as long as we stick to the principles of sound science. Advocacy science compromises those roles, however well-intentioned you are. We lose our role, and there are some alternatives we can take to ensure that the science we all learn can walk away with a winged victory. Thank you.
Can you hear me? Okay, great. So now for something completely different. I want to talk about games. Good evening, ladies and gentlemen. My name is Jörn Schmidt from the University of Kiel. And I want to talk about games in education, communication, and science. And as we are at the ICES conference, of course, related to fisheries, which makes a bit of sense. So why do I want to talk about games? Because it's fun. Fun to talk about games, but it's also fun to play games. I mean, every one of you, I suppose, has once in his lifetime played a game. Or is there anyone who has not played the game any time? Okay, that's great. That's a bit of a relief. And actually, the people have already invented games quite early in the history. So these are two examples of very early games. So the one is a Cynic game, which is played here by the Queen Nefertari, and the other one is a royal game of Ur. And as you can see, those games are already like 5,000 years ago. So what are games? We can define games as unnecessary obstacles we volunteer to tackle. Well, I think this definition is not from me, but I mean, it's quite a nice definition. And games consist of four main characteristics. They consist of a clear goal, they have limitations through rules, they have a feedback system, goals, and as we have seen before, they have voluntary participation, so you're not really forced to play a game. But it's not only games, as we know, like tabletop game things that you can play, but children, for example, also play from the very first time on they can move. I would suppose they start playing already as an embryo. And not only human beings are playing, but also animals are playing. And this shows us something that makes playing so important, because animals, they play to learn something that is serious, important for their lives. So they are playing to learn to hunt, they are learning to deal with the environment, they play to deal with other animals. And one big inspiration for me was this woman. This is Jane McGonigal. She's the director of games and research and development at the Institute for the Future. And she is actually a game designer. And she is advertising role of games also for society. And one interesting statement she has made with respect to this massively multiplayer online game World of Warcraft. Until now, gamers spent in total nearly 6 million years playing World of Warcraft. Unbelievable! I mean, to just set it into a kind of frame, 6 million years ago, the human beings. So, what an amount of time spent playing. So they really take that serious. I mean, that's something that just really struck me. But the important thing is, I said that you play games to learn something. But you can if you look at our school system, then normally what you would supposed to be learning is repeated reading, memorizing, testing, and then reading again, memorizing, testing. Is this really the way we should learn? Is this really the way we should treat our education? Or shall we not try something else? And this is a slide I took out of a presentation from the RS Animate, from a talk by Sir Ken Robinson about changing paradigms in education. And as you can see here, this poor boy, he should listen to this very boring stuff while all these very interesting things are around. Fisheries, yeah. And you can also use this, of course, in education in fisheries, with fisheries perspective. This is a very easy game, so you already learned something from that game. I mean, you learn to handle your hand and so. But one famous example of a game used for education in fisheries is the Fish Banks Ltd, developed by Dennis Meadows, whose name is related to also the Club of Rome report thing. And here are people playing this Fish Banks game. And you already see that there's also this communicative part in it. And then I looked if actually these games are already used for communication. And this is one example. This is called Reef Game. And that was used in a scientific study to explore alternative livelihoods in coral reef conservation and fishing communities in Southeast Asia. And again, you see the people here around this game, communicating, talking to each other, trying to find out what will happen if I do that, in the context of a game, which is quite striking, because some of these people would have never talked to each other before, because they said, well, you're a bad person, you are a bad person, so they would have. So what can you take out of it if you want to bring it to the science? You can investigate incentives, you can investigate strategies. So you can use games together with stakeholders to find out what are the incentives from different management measures, what are the strategies they take to do things. So these kinds of games are role-playing games, and they are actually very often used already in land use management systems. And here is an example where you have the paper part played directly in some of the households, and this was brought to a computer tool. And this is very interesting because games can be used to produce nature publications. I mean, they developed a game and called it Folded. And this game is about trying to fold protein structures to see how this works. And that actually ended up in a Nature publication. So thank you very much for your attention.
Okay, so as you see on this picture, and probably hear from my voice, I'm having the flu, and I'd actually given up on giving this presentation. But then, under a glass of wine, Martin and Ingeborg have persuaded me to do it anyway, so here I am. And next slide, please. Okay, so my presentation is about the gap between desk scientists' knowledge and fisheries reality. Now, I've experienced this gap myself as a desk scientist, and I think this gap can be very detrimental to our understanding of how to deal with certain fisheries problems. And in 2004, I talked to a fisherman, and his name is Jan van den Berg. And yesterday I asked Martin to find a picture for me of this fisherman, and he came with this one. But I'm not sure whether this is Jan van den Berg, the one it should be the white man there. I don't remember how he looked like in 2004, but I'm sure that this is his boat, because he had the UK 243. He is a fisherman from Urk, the most famous Dutch fisher town. And when this man talked to me about his fishing practices, I learned something from him that is still inspiring me in my thinking. And I'm sorry about this bloody picture. I googled eye opener. So what I learned from this man was an eye opener for me. I'm thinking about the mixed fisheries problem. Because here we go. Now, I worked on the North Sea flatfish fishery then, and the main target species are plaice and sole. And I was told that the problem there is that they are caught unavoidably together. So when a fisherman fish, he gets a mixture of those in an unavoidable way. And the problem then is what you see here, that if the fishing effort that is needed to fish, let's say, the quota for species A and species B doesn't match, then you have a problem. Because, next slide please, what fisheries managers could do, they could say, okay, we forbid them to go on fishing as soon as the quota for species A is fished up. But then you have a problem, because then you underutilize the fishing opportunity for the species with the, or for species B. So the other option that fisheries managers have is to let them continue fishing until the quota for species B is fished up, but then you get the unavoidable bycatch of species A, the over-quota fishing, and these fish are not landable, so they have to be discarded. So there are two undesirable outcomes. Now, there have been many tools developed to deal with the mixed fisheries problem, which try to give a compromise between these two undesirable outcomes, the overfishing or the underfishing of the species. And these tools have become so sophisticated that they can, for example, put different weighting on it. If one of the species is more valuable, you can set the fishing limits so that the quota is really close to the one that is needed for the valuable species. But alternatively, managers may want to, next slide. Managers may want to protect the species, for example, because the stock is depleted and it needs to be conserved, and then set the quota more close to that other species. So that's what the current tools, and Cube is one of them, can do to help us with mixed fisheries management. But now I come back to my conversation with Jan van den Berg in 2004, and when I met him, I said to him, so, okay, I've learned that place and soul are unavoidably caught together. That's what I've learned. And he started to laugh and he said, no, that's not the case. Of course, we can target them separately. I can fish plaice without catching sole, and I can catch sole without catching plaice. So I said, so why don't you then? And then he told me, well, I have other things to take into my business decisions into account, and I fish where I fish because I need these other bycatch species to make my trip profitable. Now, this is the email, a literal copy of the email he sent me afterwards, and you don't read Dutch, I know that, that's why I highlighted some of the things. So he was fishing there at this position that you see in the corner, and he got a certain catch composition of 5 species, doesn't really matter what they are, but you see them in the bar diagram at the bottom. And then he told me in this email, when he goes 20 miles to the east, he gets the same species in a very different catch composition, as you see in the bar diagram at the bottom. So he is very well able to change the catch composition in such short spatial distances. And if he goes 50 miles north, he gets again an entirely different mixture, and there's even some nephrops in the last bar there on the bar diagram. So he told me, he said, Sarah, it's just like a shop here on the water. You just have to know where everything lies. And that's a literal translation of his Dutch email. So I thought, okay, apparently there is no mixed fisheries problem, because apparently fishermen are able to catch these quota exactly. So what are we always talking about when we have this mixed fisheries problem? Now, in my opinion, and this should appear on the next slide, we talk much faster. Okay, it has to do with incentives. Because as the system is now, there's no incentives for fishermen not to go on fishing and discard these over quota catches. They are legally allowed to do that, so there's no incentive, and they have all these other incentives like bycatch species that they need to have a profitable trip. So the solution should be really to internalize the costs of exceeding the quota into the business decisions of the fishermen, so that they will not exceed the quota, and they can do that. They can target the species exactly. Thank you very much.
I'll talk about the advisory services in ICES, which we are going to improve in one direction, much more to the point, straightforward, no bullshit, and that is why we have introduced this new logo in the front of all these reports in the future. First, we have to address some salient questions here. First of all, do we know where we are now? All of us know the feeling when we are doing retrospective analysis that probably in the past we've seen these mountain goats in the mountain popping up in front of our pilots, where we simply had lost track of where we were for a specific stock. Another question, do we know where we are going? Are we sure that we are mounting the light bulbs to guide the direction where fisheries management should go in the future? Have we done that properly? Do we really know and give the directions to our customers early enough? Do we have a strategy for our own directions? Are we the leaders? Are we in front of science? And are we also in front of the application of the science in terms of marine management? Do we know where we are going in terms of smelling where the rat or whatever this dog is trying to figure out? And when we come up with errors in our projections or something which doesn't really match up to reality, are we then just saying all the time it's somebody else? Or are we trying to be more introvert and try to see maybe we have a problem on our own side? So many other questions in this. We also have to look into, are we having a bias here? Are we just the biologists who are looking at the world from a very, very different perspective from anybody else? And of course, if we want to communicate what we are doing, if we want to be relevant to the world, we need to see the world from a more broader perspective. Do we really understand the messages coming to us? Are we into a situation where somebody tries to write help and we will read it as help, then we will simply go for the help and we will turn this helicopter away in another direction? We have unfortunately cases where we have this kind of misunderstanding. Do we respect the people we are talking to? Do we really all realize that they have problems of their own and they need us to communicate effectively and we address the problems which they have in the world in a way that they can be operational in accordance to their needs? And of course, when we are presenting our scientific advice, do we really do it in a language which they pick up? Or do we do it in a way where they will only understand, because of the scientific lingo, which is far from their world, those aspects which they recognize in their world? And then, of course, in the end, are we really set up to deal with these issues? Is the way we are organizing ourselves, and especially the tools we have at our disposal, are they up to the immense size of this task which we have to address in order to deliver relevant science? So, now we have to move to the ICES plan to improve the advice communication, which is a scientific undertaking which is worthy of ICES. And I will explain you, we have been through some experiences in developing this, so I will start with the experiences and then based on that, in an adaptive way, how we are then developing it. The message for the first take a risk was to walk around, to talk to somebody, have coffee somewhere and talk again, meet some more, and have some meetings and ask some questions. And then, of course, rigorous qualitative data analysis and subjective selection of whatever. The question there is this is in accordance with the GX guidance. We have this questionnaire. Think one of the following. You don't answer the question, why is this irrelevant? It's wrong. We don't care anymore because it has taken too long. And we have changed our minds anyway. Your advice is inconsistent with the one you gave for red hair in 1996. Are you mad? Are you sure that I saw it? I don't have a clue what we're talking about. Did you ask about this? And the quick version, all of the above or forget it. These are the results. Sorry, I'm very sorry about this. I dropped all the slides on the floor when I entered the room. It doesn't matter, it's upside down because it's in Danish anyway. So but what you can see here is that the statistics coming out of this is unfortunately not robust enough to give us the real conclusions. This is clear. So we will now set up a new process where the ICES Secretariat will be tasked to give a report to the Council on how to proceed. The Council will make a study advice evaluation of the science. This will then, in the end, lead to a Council establishing which will support the study of the Council and the ICES Secretariat on this process, which will then be and this act will beat PGCC DBS. And we will have a draft format proposal for a client questionnaire in the end coming out of this process. And we are looking very much forward to this. We have a timeline for this. The Council will decide and establish this Council and then we will have the supplementary study group. And then, once we have that, then we will have the report from the consultation. The brewer will deal with it into the consultative process, and by 2015, we will have a draft formal proposal we can work on. And I think this is a grand future for the advice. Pierre. Where's Pierre?
the other meeting.
So, Pierre was here because he forgot the prize. But I'm not going to do his talk. So let's just have a look at the slides.
This was important for the last year's best
So I just thought I could talk a bit. So Marie-Joëlle won the prize, and we asked her this year to bring it so that we could give it, and she's working very hard. So that's why she's not here, because she's working very hard. Yeah, I haven't seen these slides before, so I just have to make something. I saw an email she sent to Martin last week in which she explained she couldn't bring the prize because she was working very hard and she couldn't come here. But she promised to give the... Yeah, well, anyway, my task, bring the prize. That was Pierre's task, because Marie-Joëlle asked Pierre to bring the prize to the dance so that he could give it to us, because that prize of last year, Marie-Joëlle could only keep it for 1 year, so she was supposed to give it to us so that we could give it this year. Now, on the travel day, oh yeah, I have no idea what happened on his travel day, but apparently everything went wrong on the traveling day of Pierre, so therefore he couldn't. The short story is he couldn't bring the prize. I don't know why. Things happened on his travel day. He was busy packing, yeah. So he was busy packing and he thought, okay, I need to bring this prize. So let me put it in a very clever place so that I don't forget it. I think that's what Pierre thought. I have no idea, but that's what the crucial thing. Now, so probably Pierre was busy packing and thinking all the time of the prize. But he was distracted. You see, that's always what happens. He was distracted. I don't have children, so I don't know how that feels to be distracted by children, but he was distracted by his children that had to go to football.
Just wait.
Just wait. As the answer comes why he was distracted. Okay, the daughter was upset. Yeah, well, that's something I can relate to because I know some people who are sometimes upset. But yeah, okay, so we had to comfort the daughter because that always has priority. We know that. When somebody is upset, you have to go. That has priority. I don't know why he went shopping. Perhaps he told his wife to care about the upset daughter and he went shopping instead. I don't know why.
You don't have a daughter.
He didn't have to buy a prize, I think, because he had one.
I think he needed chocolate for his daughter.
Chocolate for his daughter, okay, yeah, that's probably it, Clementine. I'm quite sure it is that. He needed to buy chocolates to comfort the upset daughter, yes. And then there were queues, so it took a very long time for him, probably about 20 seconds for him to get through. And then he had to fill up a car, and that also took 20 seconds. It was actually not very long. 20 seconds for filling up the car, but 20 seconds for just standing here not knowing what comes next. I just don't know why I did it. So, of course, he was stressed. We all know what that feels like to be stressed. So, I don't really have to explain much about that. Stress, it's horrible. But I know the solution. You have to come and live in Ireland because there you don't be stressed. Okay, he had to kiss goodbye. I don't know whether he wanted to kiss goodbye to his wife and his children, or I don't know what, but kissing goodbye is also very important. Don't forget to kiss goodbye. But of course, it's a pity if you don't forget to kiss goodbye, that you forget other things. So there he went with his suitcase to Paris, London, and Rome. So round about the trip. Because he wanted to end up in Gdansk. But he arrived. We know that because we have seen him. And he had his suitcase, and he was running. I don't know that for sure, but he was totally running because you always have to run when you're stressed, because then you arrive too late at the airport and so, and then you have to run. And then suddenly he realized, yeah, okay, I have my suitcase, yeah, okay, I have a suitcase. Perhaps he was already realizing then that the suitcase, no, not yet, into the airplane, Air France, because he flew to Paris, and then London and Rome. He's French. So, unfortunately he traveled with Air France. But yeah, and then suddenly he realized it while he was sitting in the airplane, because the picture there in the top corner is a photo of the prize that he was supposed to bring. And he looks very upset now himself, so perhaps he needs a job, I don't know. Because he suddenly realized he did something wrong. And now he wants to do something about stress relief. That's a good idea, stress relief workshop, yes. And another thing to do about stress relief is come and live in Ireland. Not everybody gets the opportunity to do that, of course. So, yeah, okay, he made it. I don't know what he means with it, because he is not here.
I'm in the wrong place. Mark tricked me the other night. I said, are there any serious presentations? Oh yeah, a lot of them are serious or about science. And I couldn't get mine into a session. So, anyway, sick, but this is not too long. This is what happens when you stop fishing. The blue line, if effort goes down, fishing mortality, stock comes up. Basically, that almost all stocks recover when you stop fishing. But there are a lot of exceptions. Sorry, there's only one exception that was found in the Uncovered program. And it was in the Gulf of St. Lawrence. But there's another one. This is off the eastern Scotian shelf, where we can see from 1970, then the thing collapses, and the fishery stops in 1992, but it just keeps going down. So this is the second major example of non-recovery that we've seen. This is an example here. I'm sorry there's so much science in this, but I have to do it here. Basically, when the fishery, the dotted line, when the fishery is closed, you see the red line, that means fish are dying. So all sorts of fish still dying, even though no fishery, and we have no explanation. Now, the fishermen think this might be due to the grey seals. So they've been, since 1960s to the present, they've been going from about 3,000 to 300,000. 12.5% increase, they're doubling every 7 years. Perhaps they have something to do with this. So what we decided to do was to try to come up with a predator-prey model between seals and the cod, and there were 4 parts to it. One, how many seals are there? Secondly, do they eat any cod in the first place, and how much might that be? What size? They go for little ones, big ones, avoid the big ones, go for the small ones, we don't know. And then if there aren't very many cod, how do they handle it? So anyway, how many seals are there? This is sort of the data. You see really good fit. All the different models show you the same thing. This is the number of pups on Sable Island. They're really growing a lot. Exponential growth going on here. So anyway, because of that, we get a really good estimate, which is going to come up in a second. You can see here we are from 1967 to 2047, exponential growth. We think it might tail off at the top, around 250,000, 300,000. The red one is the Gulf of St. Lawrence seals. It's another herd, which seems to be growing exponentially as well. Nevertheless, well, this is the number of seals we're going to use. Secondly, do they actually eat cod? Now, there's a lot of debate on this because most of the Canadian scientists say they don't eat cod. But when you look in the stomachs, you find cod. Fatty acid says they're not eating cod, but when you open up a stomach and kill it, there's cod in there. Basically, anyway, sorry I got about that. How many cod? I missed the thing. The seals are foraging, so we want to know where they are. So how many are on the eastern Scotian shelf? We get from tagging data. So we want to know, because there's seals from the Gulf going onto the shelf, seals from the shelf going to the Gulf. So we need tagging data to tell us really how many seals are there on the Eastern Scotian Shelf. And from this table here, believe it or not, if you follow one line, the 4VSW one, on the top you know how many seals from the Gulf are feeding on the shelf and how many from the shelf are feeding on the shelf at each season of the year and at different ages, so on. So from this basically we can know how much food in total our grey seals eating. And the black line tells you how much they're eating on the Eastern Scotian Shelf, the area that we're worried about, because that's where the cod are dying, a lot of them with no explanation. The other two lines are how much eating in contiguous areas. But basically this is a conservative estimate. Seals are eating up to 300,000 tons a year, at least, no, 600,000, because there's 2 tons per seal. Okay, proportion of the diet, I got to this a little bit earlier, a lot of variability, but a significant proportion of, when you open the stomach, is cod. Generally around 10, 15%, except fatty acid says none. So we said 13%. Let's go for 13%. But if they're eating 13%, this is the cod going down, and this is the seals consuming them 13%. At some point there is no cod left. So at some point they're not eating 13%. So perhaps we need some sort of a type 2 functional response. Predator-prey. So this is it. This is a multi-species BPA type 2 model response. Doesn't fit the data very well. But basically over a portion of cod. All I have to say, the important point is, even when there's no cod, there's still a lot of cod in the diet of the seals. So then we said, are they avoiding the small ones or taking the big ones? We don't really know. So we did a partial recruit for the seal fleet. And we said the flat top is they don't avoid cod. And then the other one, they do avoid cod. So anyway, when we do our model, this is the flat one where they don't avoid cod, and basically with very conservative assumptions on numbers of seals and so on, the mortality overall. Now, the brown one is what the seals are taking. The yellow one is what we don't know. And the blue one is sufficient. And what you can see is there's a lot of unknowns. Basically the unknowns is if you look over there on the axis, between up to 10 to 15%, if they're eating 10% of the diet, all the unknowns is in the seal stomachs. And that's basically the conclusion we came to with reasonable assumptions, reasonable presentation. We say, lots of seals. Seals account for most of the total mortality we've seen, which is up to 60-70%, well, I'm exaggerating, up to 50% are dying of something. And at present levels of seals, cod will not recover. So anyway, this is our projection into the future. We're a little bit taking some liberties with the data problem. Our line predicts the blue line. If their seals stay there and they're doubling every 7 years, basically they're screwed. Now, it's a break time.
The break will be 2 Pecha Kucha, so we have 13 minutes and 20 seconds. I don't know how we will fit all these people into the small bar there, but the ones in the back are probably the best place. So run for it. Okay, so there's hope. Very good to know. This is one of the events where Mark and I are evaluating a little bit of creme brulee in the ICES Secretariat, I think. This came up in a meeting in Halifax, and you have these 2 people that are always traveling, always in restaurants, always thinking about eating nice stuff. So we set it up as a study group. It's something really important. It's also very serious, because it's part of the fish philosophy of having more fun in your work. And we're trying to implement that by doing a global survey on creme brulee. So we're looking for a census of creme brulee as a sequel to the senses of marine life. We go around and try and sample as many restaurants as we can, and everywhere we go, we will try and sample creme brulee. And we have developed a specific methodology for that. So we also set up a study group with terms of reference. Of course, well, they have not been formally agreed by SciComm, but in practice they have been agreed. And it's really talking about setting up the methodologies, sampling protocols, how we report, how we define the creme brulee, so all the traditional stuff. And we needed a SharePoint type as well, of course, so that we can share information, share the pictures, do all the sampling, and then do the statistics on the sampling as well. So it's just like a normal study group in ICES. Except that the membership is a bit more free. So how do we go about doing a sampling of creme brulee? Well, there's a couple of statistics on where you do it, location, the date, but the most important is the items of the creme brulee. So how is the crust? What sort of vanilla is used? What is the temperature? What is the depth of the pudding? So we have all these scoring things. So we also developed our own sampling mechanism with a special spoon. A spoon over here. This is a normal spoon, you can't use that. If you're in a restaurant, throw it away. So you take the special creme brulee spoon and you use that to measure the thickness of the crust on the creme brulee. This is an overview of the members. A very liberal membership. Anyone who wants to be a member can be a member. Inside ICES, outside ICES, age doesn't matter. And it's going very well. Last year in Nantes we did a very good job. This is some of the results that we have obtained so far. This is the quality of the creme brulee on the bottom. We need a graph, of course. And this is the overall rating that we have observed. There's quite a few in the 7, 8. So it's not so bad. And there's a few on the 10 as well. Which are the 10s? Well, I think the one on the top is very interesting. That's Bodo Chemnitz, one of the members of the creme brulee. She has rated herself as a 10. So next time we get ICES, we will go and visit Bodo and ask for the creme brulee in her kitchen. That would be my suggestion. Now, Neil Holford is also a very active member in the study group. He developed this wonderful application that we now can start mapping our sampling activities. It's fascinating, just on your mobile phone. You can also see that the members are not so technologically advanced yet, so we only have 5 sampling sites. Okay, why is ICES such a good organization for this? Well, we have a workshop on sampling method for recreational fisheries. I don't know why we shouldn't have a workshop on recreational creme brulees. So we have the network, people go all over the world. We have the sampling experts, we have just done. Some of the things that you find, people working on the EC labor law and applying the precautionary approach. It's a very difficult job to make the creme brulee. So this is one of our sampling events in 2 years ago. And the way I operate this is that everywhere I go, I have a project meeting, and I turn it into a creme brulee meeting. It's a very easy job. So you just make sure that in your project meeting, you always go to a restaurant that serves creme brulee. This is Jackfish project meeting in Brussels. 10 new members. But be careful. There's another creme brulee, a worldwide effort on sampling creme brulee. So there's a competitor, or a group that we can link to. And they have their own rating system, the creme brulee box. We have to find out what it is. So in the creme brulee study group, we are looking for people to sample, but we are also looking for mapping experts, we are looking for sampling methodology experts, and we are looking especially for WizKids that can make these nice apps for our mobile phone so that we can do it all on the mobile phone. And my secret ambition is that the study group on creme brulee will co-host a conference dinner in 2012. Think of it, 800 samplers in the conference dinner, sampling creme brulee, and not just one, but all different types of creme brulee. So, please join us. Yes. forms if you want to become a member. Thank you very much.
Thank you. I had a girlfriend once, and she told me, Yasuno, you shouldn't tell any jokes to anyone. So I will talk to something I didn't know. So fish behavior using acoustics. Here we go. 100 years ago, there were two things you could use acoustics for. Detecting the bottom and detecting submarines. Now, detecting the bottom is a pretty good idea if you're running a vessel. Detecting submarines is not so bad if you're on board. And that was fairly relevant at that time. Now, I'm not sure if you know how an echo works, but this is how it works. You send out a sound beam, it hits the bottom, you get reflections back, you time it, you know the speed of sound, you know the depth. But you also hit fish schools, which is what I'm interested in. But people have done that before. And in 1935, the first paper using fisheries acoustics to map the spawning aggregation of cod outside of Lofoten was published. And what you can see here is a very thin layer of cod. We didn't know that before we had the echo sonars. I'm sure the fishermen did that, but we didn't. So, but you can do more than that. You can actually get the echo energy that comes back from the fish. And the neat thing is that energy is actually proportional to the number of fish. It is quite amazing, and you can use that to map out how many fish are there out there in the ocean. It's just kind of a difficult task. So if you do like this, you just run a survey, count the fish, you can get the distribution, you can get the abundance, and then you know how many fish there are. But I'm more interested in fish behavior, and you can also use acoustics to detect fish behavior. That's really what I like to do, and I think it's very, very fun. So this is, if you put an echo sound at the bottom, you look upwards, it looks like this. This is a hair layer. So along one of the axes here is time, and you have depth. Now, if you take a vessel and you run over this aggregation, what do you think will happen? Well, the fish don't like that. And what you can see here is that the fish really respond to what the vessel are doing. So this is a conventional vessel. The other one here is a silent vessel, and you don't have to do the statistics. It is quite amazing. This is how you actually change the behavior of a fish when you do a swim. But you can do more than that. You can actually track individual fish inside an echo beam, so you can actually figure out what the fish is doing. And it's a very simple system. If there's one fish, you can actually know exactly where the fish is inside the beam. And you can use that to pull out the fish behavior. And this is something I did before. I put in a buoy system, and I used this principle and then figure out what's the fish doing. And we were able to track individual fish in the Barents Sea and figure out what was the response to this vessel. And what we found was that 15 minutes before the vessel arrives, you actually change the behavior of the fish. So think a little bit about that when you do your surveys. You are actually changing the behavior to what you see. Is Heisenberg on a quite different scale. But I mean, what I really want to talk about is fish behavior, and that's what I'm interested in. So you can put an echo sonar inside a lake like this, and what you see here is individual fish inside a school. And you're using the split beam principle, you can actually track the fish. You can figure out what is the fish doing inside. But you can not only get the trajectories of the fish inside the layer. You can, if you look at one of the tracks, it looks like this. And you can see the periodicity of the signal. And the periodicity of the signal is actually linked to the tail beat frequency of the fish. And then you can have two adjacent fish. You can actually see how they behave in relation to each other. Not only the trajectories, but also the tail beats and how they link. It's pretty amazing, I think. Then you can do sonars. And I'm sure you've seen many of these sonars. And I'll show you some examples of what you can do with sonars. So this is one in the corner is a very small scale. This is very large scale, and the top ones are vessel scale. Now, this is a Sprat school. what I'm interested in is how does the fish actually behave inside that school? There's a lot of dynamics, and I think it's very fascinating. I hope you think so too, but so, but in order to figure out that, we did some simulation. This is a PhD student of mine. So if the fish are like this, you get a strong signal. If it's like this, it's a weak signal. And you can see by A and B there, it's the same amount of fish. And then I like the donut. I mean, is this a vacuum inside the scale? I don't think so. The density is constant. It's just that the orientation is different. And if you look at this is real data from the Barents Sea. This is herring. And if you look at the dynamics of this, it is actually behavioral changes inside the school. I think this is very fascinating. There you go. I mean, there's so much dynamic behavior inside that schools. I think it's just amazing. Now, this is something on a very, very different scale. This is Nick McCree's work on MIT. This is hundreds of kilometers. It's a huge area. You can actually map how schools forms. But I've been working on much smaller scales lately. I can actually go in to look at the predator-prey behavior on a very fine scale. And here you can see, I like this video. This is Gulf of Manhattan in the Gulf of Mexico. And you can actually see how the predator goes into the school, how the information flows through the school. It's pretty pictures. Well, that's my opinion though. So if you're interested in knowing more about how can I extract qualitative behavior, you have to come to my session.
I'll give you some advance warning, this isn't going to be funny. So, hi, I'm Paul, I'm at the University of Aberdeen, and along with Nick, who's at Marine Scotland Sciences, where I used to be, I'm going to be talking about discards, and it's in relation to the European context with Eco-Fishman, which is a European project which has that in its remit to look at different fisheries management regimes, and discard mitigation is very much a part of that. Okay, so what are they? Well, it's the portion of the catch that is dumped at sea, dead or alive. And it's a worldwide problem, but locally it's got a lot of attention recently because North Sea cod, for example, recently was discarding half the catch. And obviously it's a waste of food, but some people argue it's a source of food, particularly for birds and for benthic invertebrates. Various studies suggesting that some birds are actually dependent on discards. Anyway, it's still a problem, waste of food, and it's caught a lot of press. So the fishing press has been getting hold of it, and the BBC even got a video on it. And recently there's been a celebrity chef in the UK called Hugh Foley-Whitstall who's made a big deal out of it, and the public now are getting really concerned. So we really need to do something about this. He's even got a petition there, you can see 750,000. So why does it happen? Well, fishermen, they go out and catch their commercial fish species, they're trying to get some landings out of it to get some marketed produce. Lots of different species in a mixed fishery, this is where it's a real problem. And we catch things in various systems, but they're not particularly selected, whether they be trawls, gill nets, or long lines. It's a bit of a mixed bag that you're actually catching. So the first thing you do is you get some bycatch, and this is your traditional megafauna, such as seals and turtles, occasionally, but quite often some charismatic fish that we don't necessarily have a market for, and other invertebrates and other fish that we necessarily don't want. We can't manage at the moment, although maybe the Marine Strategy Framework Directive will change that. But we also end up catching things that we don't want, small fish in particular. We've known about this for a long time. The undersized and less than mean landing size. And this is a time series, and you can see that we've known about it for a while. There's been some discards, but recently the actual discards in the North Sea of cod in the fish trawler fleet has actually been coming down. So what's the big problem? Well, this is the problem. This is the same data set, but for the marketable fish, not the big fish, the big fish, West Coast and North Sea, and you'll see that for years there was no problem, but in 2007, bang, massive amounts of discards. And this is for two reasons, partly availability, but massive increase in compliance. In 2005, increase in compliance, they couldn't blackfish, and therefore you have this high amount of discards, which are regulatory over-quota fish discards. There's also another component to that, in the large fish, that fishermen make certain decisions about discretionary discarding, which is based on their market availability for high grading, or in the pelagic system, there'll be slippage. And just to complete the picture, there's more. So, solutions, right, here we go. So, 10-point plan, which I suggest we act on a regional basis, which is very much in the CFP reform. I'm going to go through each of these very quickly. They are colour-coded from the easy things you can do right up to the real hard things, which is number 10. Okay. And the first one is decoupling fisheries. So using some sort of technical measure to actually go with what you're aiming for. On the right-hand side, you'll see a Nephrox trawl catch with the 80mm mesh without a grid. This is what normally happens. On the left-hand side, you see a Nephrox trawler using a grid, and lo and behold, he catches Nephrops. So these systems are available. There are other technical measures for various different fisheries. Number 2, spatial avoidance. Get fishermen to avoid areas, either through regulations, and an example here is real-time closures, which happen in the Scottish Conservation Credit Scheme, where you set up a whole lot of areas either to protect and identify areas of juvenile fish and or adult fish. And this is a study that was produced by Stephen Holmes and others, Nick included. Okay, ITQs. Give fishermen the ability to swap quota in and out. This is an example from the Icelandic Directorate of Fisheries database, which is available online, showing you what the quotas are, what the catches are for individual vessels, and people can see that. It's very transparent, and they can see it within 6 hours of that catch being taken. This is my only joke. Bank and borrowing. So this is where you allow some sort of quota flexibility, where, for example, in 1 year you allow the quota to be going over by a certain percentage, providing in the next year you borrow it back. Number 5, new monitoring. Talk to Howard. This is about CCTV, giving fishermen the opportunity to show that they're not actually discarding fish, and the Danes have been very active in this. We have Scottish and English systems now where CCTV is in action, but it also means other types of monitoring where you might inspect the length frequency of observed catches and compare those with landed catches. Quota need. This happens in Iceland. Unless you have the quota to go out to sea, you can't go to sea. And providing you have all those other steps, particularly an ITQ system, then there's no reason why you shouldn't be able to get quota. And I've seen fishermen negotiate on a train with me saying that they need to buy quota, so they'll just go off and do that and talk to their POs. This is where the celebrity chefs come in. New markets. It deals largely with the bycatch issue, but they're talking about creating new markets for these fish that they catch, like grey gurners, red gurners, and pollock, some of the invertebrates, and even fish sausages, that is a real picture of a fish sausage for the offal. And so there are plenty of potential to maximise the catch of the bycatch. Okay, getting into the realms of the dark reds, international and individual transferable quotas, a little bit more difficult, but still possible. It happens at December Council. There are trade quota swaps, and if you've got the producer organisations to get together, international ones, then I'm sure they could have some individual transferable quotas on an international scale. Number 9, Sarah's already done this for me. When you reach your particular quota for a particular species, the fishery is closed. And this is the mixed fish sort of option where in the current system, the different bars represent the different catches. And in the left-hand side, you see when it reaches cod, you stop the fishery and therefore they don't catch much of the other species. But with all those other measures, that might change. And then finally, the Pandora's box of relative stability. You have to look at the catching opportunities and relate those not to the historic catches, but what's actually on the ground. And this opens up a Pandora's box of zonal allocation, all the rest of it, but there's no reason why we can't provide the science to have a look at that and avoid the problems that we're getting in mackerel. So I suspect that many of these measures will be included as part of the CFP reforms. Maria Damanaki has already mentioned that, and with a little bit of luck, I have some confidence that we can solve this problem. But don't tell the seabirds.
Thank you very much. Two speakers who are sat there from Scotland, but both of us aren't Scottish. I'm an Aussie. That's a picture of me when I finish the talk, what I'll probably look like. That's Angus. He's a 94-year-old fisherman from the west coast of Scotland. Seen a lot of changes. We've done a big survey across Europe, 7,000 people asking them what they think about the sea, their values towards the sea and oceans management. There are a lot of pressures that are emerging. This is a picture from California, urbanisation of the coastal zone. It could be in many parts of the world, it's a real problem. Responding to a range of pressures. This could be particularly susceptible to climate change, as could this picture. Quite a disturbing picture, but I think what it says to me that people around the world are incredibly reliant on ecosystem services, not as a statistic, as a figure, but as a daily existence to survive. And this is one of our first climate refugees from Bangladesh. Our survey showed that the health of the world's oceans actually ranks quite low amongst several countries in Europe, amongst our 7,000 studies. This is just a snapshot of them. But of course, we have variations in Germany, but against things like cost of living, the economy, affordable energy, the oceans do rank relatively low. We value the oceans for a whole lot of reasons. This one is the financial data on a regional sea basis from fisheries. So there's quite a lot of money being extracted out of the oceans. I don't believe this contains subsidies, this data set, but there are 2 billion euros from the Mediterranean. People do value ecosystem services, however. This is a positive note from the study. The blue bars relate to cultural or aesthetic values. They rate quite highly compared to the more traditional economic values that people associate with. So weather and climate and scenery were ranked relatively high as a result of the survey. However, we have problems in the way we communicate marine science. The first three things, the highest three rankings here for impacts on the oceans, pollution and litter, and oil, they are the highest things, whereas climate change and acidification of fisheries ranked down the list. I see that as a major problem facing the communication of science. When it comes to climate change, it depends on where you're living. If you're living in the UK, the bottom line here, a third of the people actually think climate change is a problem in the UK. The top two lines are from the Mediterranean, Portugal and Spain, maybe because it's warm there. Maybe the UK could be quite happy to get a few extra degrees, I don't know, that's coming out in that graph. The green and the purple bars here are scientists and environmental groups. They're seen as more legitimate managers of oceans and ocean resources than governments and industry. We found a statistical difference between the two. I think this really says scientists and NGOs can be real change agents for the future here. Governments are facing real problems when it comes to the implementation of the Marine Strategy Framework Directive. This is an output from some work we did in the UK where potentially 90 different pieces of law relate to the implementation of the Marine Strategy Framework Directive in the UK context. It's complex and it's hard. What does the future hold? It could be a variety of things. We've got problems with governance, we have real challenges in different parts, and it depends on the social and the cultural and the institutional mix of where you live, and we have to figure this out. This is a real challenge for geographers, social scientists such as myself. There are opportunities for very innovative management. This graph looks at support for marine protected areas. You look at the left-hand bar, it's overall for Europe in our survey, 75% of people think MPAs are a good idea. The UK and Poland are, well, about 60%, but there is generally quite an optimism facing marine protected areas. Same again for marine spatial planning. The red and the blue graphs, about 75% support the concept of marine spatial planning. We had to spell out what that was in the survey, so there is a general optimism for it. However, we don't trust the government particularly much to implement it, so there is a role for scientists and NGOs. Conflict or cooperation? What will happen here when we forward plan for marine governance in Europe or around the world? This also could be a science policy debate. Is science policy on the left or on the right? A bit of conflict and a bit of cooperation in all these instances, and they're actually both sides of the same coin. There are opportunities, however, for innovative approaches such as market-based approaches. This is a sample from the UK consumers, where about 30% actually recognise the Marine Stewardship Council logo for sustainable fisheries, and about 70% have absolutely no idea about the label. But there are opportunities there to develop new markets. So I can get a new microphone, isn't that nice? Singing number now. I stood in Tesco's all over the UK to get this data, mind you, so Tesco's and Co-op, and we found that there was a real, you could say this is optimistic or it's not optimistic, but where do you stand on the ice? It depends on where you live. Are we in trouble? Are we not in trouble? If you live in the Arctic and you're an Inuit hunter, then your way of life is changing. If you're living in Bangladesh, you are reliant on ecosystem services. If you're living in a developed country, I think the changes are far more subtle, but there are changes coming nonetheless. We have this thing called the ecosystem approach, and we like to talk about it, but we don't really know what it means. However, social aspects are fundamental component of the ecosystem approach. Societal choice, decentralized decision making, broad use of scientific and traditional decision making. So despite the various differences in nations, concern for the marine environment I think is rather low. However, there is optimism. Scientists and NGOs, you guys, are held in high regard. I think this is a real opportunity to act as change agents and must have democratic, science-driven and community-supported initiatives that should drive governance. There are some crazy ideas out there about where the future is going. These things are called sea settings. They're autonomous installations that people live on, countries floating in the sea. There is a thing called the Sea Setting Institute. It's crazy, but I think it's quite exciting in terms of the experimentation of governance and that we could see in the future. My real objective here is to say, think big, be ambitious, challenge government, and work together for a much more sustainable future for the seas. Thanks.
Sorry. Quick confession, I'm not doing this for any other reason than I can put the logos on and then I can put it in my annual report. And then I realised I hadn't put my sponsors on, so I can't. So I'm going to sit down. So this is our project. I'm going to use a lot of words on my slides. I always teach my students never to put words on slides, put pictures on slides. But I'm going to put words. Anyway, the important words are the EAFM, you know about that, and Ireland, because they pay my salary. And so we're going to talk about the EAFM. Now, when I last gave this presentation, somebody asked me what the EAFM was. As you can clearly see from this, it's simple. Oh, and if you didn't like that, here's one telephone directory. Here's another one, and here's another one. So, what you've got is lots of words describing the EFM, but what is the bloody thing? Somebody just asked that question.
That's really exciting.
It's the topographic setting and it isn't quite the EFM, but we're hoping to convert it into the EFM. This is a tag team.
So I use this opportunity, as opposed to my predecessor, my talk has gone, so I'm already trying to get a bigger audience. So this is the area I work with. This black, white spot in the middle in the square is something that we've been surveying for 10 years, and we just been having the fishery data. We didn't understand what was going on. But the thing is, there was a lot of young juvenile hake in this region. This is our ship. We've been collecting data, stacking them, analyzing, into standard reports, and we couldn't say anything about the environment except that, it was warmer or colder or whatever. So we review this data, but now just trying to explore it the way how you look into the landscape. The first thing is bathymetry. That is what it goes with the fisheries, the ecosounder. We just put all this data together, and here is the map. You see all these fine features, this flat area in the middle. We didn't know about this. I mean, it was all aquatic region. Now, that thing will shows you what this area on the left as a reference on the figures. So you see following figures. So see some of the bathymetry features in that one in the top. It's just nobody knew about this. And here is this child's bug thing, what is the role of that? How it stops the flow, how it guides the fish through. I mean, it just came out simply exploring the data. And here we just use satellite imagery on top of ADCP. This ADCP, the currents are quite chaotic, but if you look at this filaments, eddies, you know it's not chaotic, just this ship cannot cope, with the speed of survey. Now you see that this makes sense. It's a lot of export from the shelf. Here, well, it's a different season. The currents are more regular. Well, we know the larval transport is more regular during the aquatic season. And that actually comes by overlaying the data. We didn't do, we just reported it. Okay. With this done, we look at this. Normally we look at the Puelic, at the plume, at the high salinity, but look at this little blob in the middle. It comes up in the northern part of the surveying area, and it's so persistent. It's a mid-shelf thing, completely disconnected from the shelf break. And then we start, look a little bit at the currents distributions. If you just look at those currents, you see that there's this flow to the north in the top. And there is always southward currents in the south, and you see this Ekman transport offshore. Everything is there on the data. It's just hardly visualized. Okay, we've done it. I mean, oh, well, so where is the fish? We'll try to look for it. Well, go back. We go to the south. You see this big upwelling plume in the south, and you see this goes through there, you know, and it goes to the north, and the current is actually carrying it through. So we see some really, you know, three-dimensional patterns in our survey data suddenly, you know, after 10 years. And this little block in the middle, it's always there. It's always there. So it's this persistently coldest water sitting in the middle of this open space in the ocean, and it's always colder. It's always stable conditions. And let's look a little more than we just overlay all our data. You know, this is so-called TS diagram, so it's more or less a scattering graph. And you know, between 50 and 150 meters, it's always the same. Never changes. It's a stable temperature. Winter, summer, 10 years before, 10 years after, it's always the same temperature. Even though this is a upwelling region, that's supposed to be a lot of variability. Then we use, you know, this kriging, and this is a quite blind method. Applied, it shows the blob. Anywhere from surfaces, so there's a blob in the north, or the colder water is always staying there. So that's what we think it is, that there is actually a push of the cold water from the south to the north. Then here, it's in our case, it's not the same map as in before, and here we just overlay some of the current vectors on this. It takes some time. Yes, here they are. Messy, but they show actually that things are going to the north. So here is the pattern. There is this little mountain actually creates a three-dimensional circulation and cold conditions on the top, and then comes on top of an oxygen. This is well-known thing, upwelling region, high productive, secondary productivity bottom, low oxygen levels. But let's wait for another picture. It's just come on. There's nothing more to say about this. That's been documented. So, look at that. If you look at the topography, down 165 meters, high oxygen, always. The only region in the whole area. That's it. I mean, it's a high oxygen, constant temperature, and we see young haze over this region. So, we know why it's spawning area. Sometimes it's not, but then we know that it's coming this low oxygen water from the north, overflows to the shelf, and we actually saw, I will show it here, we saw that there's less young hake at the bottom. So we understand actually what is happening. Now, and that actually concludes my talk, and here are conclusions. That with Martin we developed, you know, say at 3 o'clock, when I brought this and said, hey, I may contribute here. And we were just patching up, so, you know, this is what comes out, but the major conclusions are, you know, coming up. Usually there's a Mitchell region. Yes, it's permanent upwelling. It's variable in the top. Well, current flowing is persistent feature. That's right, and that's the main conclusion. And well, we believe that we understood why we have a nursery area in this region. Thank you.
We can hope. You know, 20 seconds is amazingly long. You should try this. Oh, right, here we go. The ecosystem approach, it's this one, thank you. It's all about managing fisheries to minimize damage to the environment and their sustainable value. And the important word is manage fisheries, so that's 2 words. And that's what it's about. And I'm hoping to get that published. That'll be like Garcia 2003, only much more modern. So, we're going to look at lots of different areas, and this is a slide that runs itself, so I'll just relax. As you can see, we're going to look at quite a lot of different fishes. These are big ones, so these ones I like a bit more, because these ones...
presentation, and I think it's very brave just to do it, and I think you all did a good job, so that's very nice. So I would like to to experience the 20 seconds rule. So this is what I read yesterday. Tell me what I will forget, and I will forget. Show me, and I will remember. And involve me, and I will know. So there we go in Pecha Kucha format. Experience the 20 seconds. Well, right, there we go. You're start thinking. Yeah, there we go. It's up to you. So to make a choice if the topic was particularly interesting, or someone really was able to keep your attention. You didn't email during the meeting, I think. We're still there. I don't see any laptops, so it's very good. And now it's up to you if you think the main message was the most important for the best presentation, or there was humor in the presentation. No humor. Perhaps it's just a friend and you'd like to keep that friend, so you just write up with her. Or perhaps the attractiveness of either the presentation or the presenter. That I leave up to you. So that's. You've got 20 seconds to think, and please stand up already because you will have 20 seconds to move afterwards. So stand up, all, and think whom you're going to reach. So please spread it out. Yeah. Just move a bit. Yeah, you can choose your presenter. Run, all of you. Who's the best? Run.
No.
You've got 20 seconds. Are you there already? Here's mine. Well, there we go. Are you really sure you've got 20 more seconds to think about? I'm just standing on a chair now. Sorry for that. Does everyone still know where he is? Well, you feel how short 20 seconds is then? I see many people here. That's very good. The poll is supported very well, I think. Barbara's waiting a minute. So we start counting the votes now. Who's in charge of poll in this area? Just start. Yeah, well, who's voting for poll? Because I cannot separate you. Okay? Because I like to see. Yeah, just lower, please. Who's supporting Jörn? Who's supporting Sarah here? And over there, who's supporting Dave? That's yours? Fine, let's get up. Okay, yeah, you're yours. Okay, very nice. I think, you're alone?
What's that?
You're alone? You're Mike, you're supporting Mike?
Yeah.
Well, I think the winner is Paul. Congratulations and kisses and whatever, and more kisses and more kisses in 20 seconds. Yeah, that's very good, Sarah, because there's not many kisses on there. So I'd like to have a big applause. 20 seconds, please. I'm going to virtually hand over the present because it's not there, as you know, because Pierre forgot. Repeat that. You cannot repeat it often enough. Pierre forgot to bring the present. So it's not there, but you will get it somehow. And so